So this is the 26th video on rigid body kinematics. This is in continuation of the 25th video. So in this also I'll take up some more problems on SRC procedure for acceleration. Okay. But again, before going ahead, I'm telling you again. If you watch the videos of this channel, you don't have to see to any other book. You don't have to go anywhere else. Okay, you can study from this video also itself. You can study. You can make a full preparation of physics for IIT, JEE Mains, Advanced and NEET both. So you don't have to go anywhere. You just take a problem from any other book, any other source and solve them. If you have any doubt, you write in the comment box. I will discuss the doubts and tell you. Okay, fine. So this I'll take up some more problems on rigid body kinematics on SRC procedure for acceleration. Okay. So now first what we'll do, we'll discuss the pure rolling criteria from acceleration point of view. Okay. We discussed the pure rolling criteria from velocity point of view in the previous videos. Okay. But in this I'll discuss the pure rolling criteria from acceleration point of view. Okay. So the problem is this. See, suppose this is a side view of a circular drum with C as the center and R is the radius. Suppose this body undergoes pure rolling over a moving plank. Okay, fine. This is a plank, okay, moving plank. This is a circular drum. Plank here denoted by M. Drum is denoted by M, okay. Plank are not denoted by M, it is denoted by M itself. Let just P itself, okay. Suppose center moves ahead at a speed Vc with respect to ground, okay. Plank translates with the ground at a velocity Vp. I hope you understand what is meant by translating plank. All the material points of the plank have the same velocity at the given instant with respect to ground. So Vp is the velocity of plank with respect to ground at the given instant. Vc is the speed of center C of the drum with respect to ground at the given instant. Suppose it rotates anti-clockwise at clockwise with angular speed omega. Suppose it rotates clockwise at angular speed omega, okay. And suppose here it undergoes pure rolling. Pure rolling. Now suppose the material point D of the drum is in contact with material point P of the plank. I hope it is clear what I am saying. D is the material point of the drum in contact with the plank and P is the material point of the plank in contact with the drum. Okay, fine. Now we define unit vector ET and EN. ET is a unit vector tangent to the drum and plank at this point ET. EN is a unit vector along inward normal. This is called concave surface, concave side, inward normal this side, okay. Now we know from the pure rolling criteria, we have discussed in great details in the chapter on rigid body kinematics. Pure rolling criteria has been discussed in great detail from velocity point of view. So that we know from pure rolling criteria, we know that velocity of the contact points D and P are equal. That is the meaning of pure rolling, which I have discussed in great details. I hope you understand it. Velocity of D and P are equal. D is the material point of drum in contact with material point P of the plank. Here pure rolling is taking place. So Vd and Vp are equal. Vdg is same as Vpg. Vpg is the velocity of material point P of the plank with respect to ground. That is just equal to Vp itself. Vpg is just Vp, velocity of plank with respect to ground. Now we have to find Vdg. For that we apply SRC procedure for velocity between C and D. SRC procedure for velocity between C and D. SRC procedure for velocity between C and D. So selected point becomes what? D. Other point becomes P. Other point becomes C. C. D is the material point of drum in contact with the plank. We draw the line joining SP and OP, that is C and D. We give the velocity of selected point C to other point D. VC we give. Now we write down the sentence. Omega of drum with respect to ground is omega clockwise. D moves in a clockwise circle with C as center and radius R. So we give omega R to D towards left. The velocity of D is the vector sum of these two. Now velocity of D will be Vd will either be written as Vc minus omega R or omega R minus Vc. We have to decide which one of them. Now here pure rolling is taking place. P and D are in contact. So tangent at the since pure rolling takes place, direction of Vd and Vp should be in same direction. Vp is moving rightward, so pure rolling Vd should also move rightward. So resultant of these two should be in this rightward direction. So Vc should be more than omega R. Velocity of Vd with respect to ground, Vdg, simply Vc minus R omega. And Vpg is what? Vp. They are equal from pure rolling point of view. So this means Vc minus R omega is equal to Vp. So this is the condition which you obtain from pure rolling criteria for velocity. Now what I do, since this equation is valid for all times, I derivate this equation with respect to time. dVc by dt minus R d omega by dt becomes dVp by dt. This is nothing but AC, acceleration of center of drum with respect to ground, minus d omega by dt is beta, angular acceleration of drum with respect to ground, and dVp by dt is AP, acceleration of plank with respect to ground. So this condition which we obtained just now. So AC minus R beta is equal to AP. This condition I have obtained. Fine. Now see. So AC minus R beta is equal to what? AP. This is clear? Fine. Now I love this one. Okay. Now what do we do? We apply the SRC procedure for velocity acceleration between the points C and D. Okay. So angular speed omega is clockwise. I assume that angular acceleration beta is also clockwise. Beta is the angular acceleration of drum with respect to ground. Omega is the angular velocity of drum with respect to ground. Okay. Now we apply the SRC procedure for acceleration between C and D. So in case you have any doubt regarding SRC procedure for acceleration, you go to the 23rd video on rigid body kinematics. There you will get it. Alright. So I apply SRC procedure for acceleration between C and D. SRC procedure for acceleration between C and D in ground frame. Okay. So SP becomes C, OP becomes D. SP meaning selected point, OP meaning other point. I draw the line joining SP and OP. That is, I draw the line joining C and D, which is vertical. I give the acceleration of selected point C to D. So acceleration of selected point C is AC rightward. So I give AC to D rightward. Okay. Now I write down the sentence. Omega is clockwise. So D moves in a clockwise circle with C as center and radius R. So one acceleration I give omega square R to D towards center. And one I give R beta to D towards leftward. Right angle to the line CD. Why leftward? Because beta is clockwise. So for clockwise beta, for clockwise beta with C as center, R beta should be in this direction. Now acceleration of D is the vector sum of these three. So ADG, G for ground. Acceleration of point D with respect to ground is the vector sum of these three. So this becomes AC ET hat. ET hat I've said, unit vector in this direction. Plus omega square R En hat. And this is R beta minus ET. R beta minus ET. So this becomes AC minus R beta into ET. Omega square R into En hat. So this becomes ADG. Okay. So ADG has a component in the tangent plane, that is along unit vector ET, and a component in the common normal along the contact point omega square R. But we know that AC minus R beta is equal to AP. So this is just AP ET plus omega square R En. So what does this mean? Tell me. See, this means, if if you see the point P of the plank, acceleration of point P with respect to ground has a component in ET, component along EN. This can be written as AP into ET plus AP into EN. AP, now what is this EN hat? EN hat is unit vector along normal, but P has is moving in a straight line, so it has no acceleration in direction normal to ET. So this AP, this term is 0. This term goes away. Only acceleration of point P with respect to ground is simply APET. This is 0. This I wrote AP, I meant component of AP along EN, APN, that is 0. So APG is equal to APET hat. APG is equal to APET hat. And ADG is equal to this. So what do you see? ADG is equal to APET hat plus omega square R EN hat. And APG is equal to APET hat. So what does it mean? Tell me. This means that component of accelerations of P and D in common tangent plane, they are equal. See, ET component of ET is same in both. But along common normal, acceleration of P and D are not the same. Can you see it? Can you observe what I am saying? I am telling that accelerations of point P and D along the common tangent plane at the contact point, that is AP, they are same. See, component of ET hat, both are same. But along EN, component of ADG is not equal to component of APN. APN is 0 and ADN is omega square R. They are not the same. But in velocity, what is happening? VP and VD are both same. They are same both in tangent plane and also along common normal. But in acceleration, they are equal only along common normal. Not along common tangent plane, not along common normal. So, what is the similarity and what is the difference? In velocity, when one body undergoes pure rolling over another, the velocity of both the points P and D, they are equal. They are equal in along tangent plane also and along common normal also. But when one body undergoes pure rolling over another rigid body, then the acceleration of 2 points in contact, they are equal only along the common tangent plane. Along common normal, the acceleration of 2 points are not the equal. So this is the similarity and this is the difference. Fine. Now this I'll rub it now. So what do you write? When, see, in this I took up the translating plank and the body was rolling over the plank, pure rolling. But we can generalize the situation. See, suppose the plank is also not translating, that is also rotating. So what I am saying is this. Let us have the general case. This body M, this is another body, say some other body, say M dash. This body is undergoing pure rolling over this. M dash. These are the 2 points of the 2 bodies in contact, point P and point P dash. This is a tangent plane. This is a common normal. Unit vector along tangent plane is ET hat. Unit vector along common normal is EN hat. So in this, what will you say? Since pure rolling takes place, so VP is equal to VP dash. When one body undergoes pure rolling over other body in rigid body in contact, then velocity of both the points are equal. They are equal along tangent plane also and along common normal also. But to derive it, I took this special case. But the observation is general nature. So one thing is what? When one body M undergoes pure rolling over another rigid body M dash, then velocities of 2 points P and P dash of 2 bodies in contact are equal along common tangent plane also and along common normal also. But acceleration point of view, what we will say? Only accelerations of P and P dash along common tangent plane are equal. But along common normal, accelerations of P and P dash are not the same. So this is the similarity and this is the difference in pure rolling from velocity point of view and from acceleration point of view. So this I equated the velocity of 2 points, they are equal. Now I resolve this P along ET and EN, this one. So if I resolve it, then what do I get? Vp et hat plus Vpt Vpn en hat is equal to Vp dash et hat plus Vp dash en hat. So if we equate the respective coefficients of et and en both sides, so Vpt is same as Vp dash et. This I'll write as t only. Okay, fine. This I'll write is simply Vp dash n. Okay. So one thing, velocities of 2 points along common tangent plane are equal, and velocities of 2 points p and p dash along common normal are also what? Vp dash n. Okay, fine. So in velocities of 2 points p and p dash in contact and belonging to two bodies, they are equal along common normal and they are also equal along common tangent plane. But in case of acceleration, what we will say? Acceleration of p along ept is same as ep dash t. They are equal in tangent plane, they are equal, but along common normal they are not equal. So, is it all right? So this is more general, but I took this example, but the conclusion which I obtained in this is valid in general case also. Fine. So this example I took up just to demonstrate the concept, translating plan, but it does not say that the body over which the M undergoes pure rolling, that it may translate, it may rotate also. So here also general conclusion will be this: velocities of 2 points p and p dash are equal in tangent plane also and common normal also, but accelerations are equal only in tangent plane, but on common normal their accelerations are not the same. So this is the similarity, this is the difference between velocity and acceleration from in the perspective of pure rolling. Okay, fine, all right. So I hope you understand this. And this, how we have obtained this I have already discussed in the great detail in the chapter on rolling motion. Which are rolling motion, you go to the previous videos, you will get it. Okay. So I hope you understand this. Fine, all right. I'll just take up one example to demonstrate the concept. Okay, then I'll close this video here. Okay, I'm drawing this. Okay. I'll take up an example to demonstrate the concept involved. See, all the details are given in the diagram. Are given in the diagram. So find the value of A by R beta, question mark. Okay. So the question is this: this is a circular drum side view. C is the center, R is the radius. Center C of the drum moves at a constant acceleration A with respect to ground. The drum undergoes pure rolling over a translating plank. This plank translates with respect to ground. Plank has an acceleration of A with respect to ground. Beta is the angular acceleration of drum with respect to ground, taken to be clockwise. Omega is the angular speed of drum with respect to ground, taken clockwise. Pure rolling takes place here. All this A and A, omega, beta, they are all with respect to ground. Pure rolling takes place here. We have to find the value of the ratio A by R beta. This I'll wrap it, okay. So this I can solve by several methods. I'll solve it by two different methods, okay. I'll solve it by two different methods. By two different methods I'll solve this problem. Okay. So solve this method 1. What we do, see, this is the material point D of the drum, which is contact with material point P of the plank. We apply method 1. What we'll do, we apply SRC procedure for acceleration between C and D and get the acceleration of D and equate its component along tangent plane to acceleration of P in tangent plane. Okay, so SRC for acceleration between C and D. SRC for acceleration between C and D. So SP arrow C, OP arrow D. Now I draw the line joining SP and OP, which is simply vertical. I give the acceleration of selected point C to other point D, 4A. Now omega is clockwise, so I write down, say the sentence. D moves in a clockwise circle with C as center and radius R. So I give two accelerations to D, omega square R and R beta in leftward direction. The acceleration of D is the vector sum of these three terms. This is the unit vector along tangent plane. This is a unit vector along EM. Now component of acceleration of D in tangent plane is simply 4A minus R beta. This has no component along ET. Component only these two. Now this point P has an acceleration of A in rightward direction and here it is no slip. So for no slip to take place, acceleration of D in tangent plane also should be equal to that of point P. So acceleration of D in tangent plane should be in rightward direction. So the resultant of these two should be in rightward direction. So this should be more than this. So we write 4A minus R beta is equal to A. 3A is equal to R beta. So A by R beta is equal to 1 by 3, which is therefore the required answer. The value of A by R beta is equal to 1 by 3 and it is therefore the required answer. Okay, this is solved in method 1. Now we can solve it in method 2 also using that concept of relative normal acceleration by separation, as discussed in the 25th video on rigid body kinematics. Okay. So I'll solve this by method 2 also. Method 2. Using the concept beta is equal to relative normal acceleration by separation. Relative normal acceleration by separation. Now you consider the line CD, which is a line fixed in the drum. This C, this is D. We know the acceleration of C is how much? 4A rightward. 4A rightward is the acceleration of point C. Now P and D are in contact. Here pure rolling is taking place. Acceleration of P in tangent plane is A rightward. So pure rolling criteria also, acceleration of D in tangent plane will be how much? A rightward. D will also have some acceleration in this direction. It will be omega square R, as I discussed just now. Okay, fine. So now I hope it is clear. Alright, fine. Now what is the relative normal acceleration between C and D? Normal acceleration of C is what? 4A in right component of 4A normal to rod, which is simply 4A. And what is the normal acceleration of D? A. That's also rightward direction. So both the normal accelerations of C and D are in rightward direction. So relative normal acceleration will be 4A minus A, 3A, by the theory of relative velocity between relative acceleration between two moving points. So beta will be written as 4A minus A by R. That is same as 3A by R. Okay. So this means A by R beta is equal to 1 by 3. It is therefore the required answer. So A by R beta is equal to how much? 1 by 3. That is therefore the required answer. Okay. So this is the value of the ratio A by R beta. And by both the methods, same answer has been obtained. Alright. So this was the 26th video on rigid body kinematics. Next coming 2 or 3 videos will also be on the same chapter. Then we'll pass over the last chapter on rigid body kinematics, that is the concept of instantaneous center of rotation. IC concept, very important concept, okay? That will be discussed in the coming videos. Alright, so I close it here. Fine, alright.